And go over the warm-up first. So question 1, I want to find g of 3. And g of 3 is 4. And then I want to find f of 4. Well, f of 4 is 6. So my answer is 6. So I want to find f of 4, which we already know is 6, just because we just found that one. And then we want to find g of 6, and g of 6 is 10. Okay? Then I'm going to slide up so the graph is a little bigger. So I want to find, helps if I start at number 3. F of 3. So I have 3 different graphs, by the way. I just want to point that out. I have F, I have H, and I have G. So make sure you're going to the right graph. So it finds F of 3 is 1, 2, 3, -4. And then I want to find H of -4. So -4 is 1, 2, 3, 4, 5. So my answer is 5. And then we want to find G of 4. So 1, 2, 3, 4. It looks like it's 2. And then F of 2. So 2 here, and F is 1, 2, 3. Questions so far? Are we okay so far? F of -4 is -5. And then F of -5 is -6. Okay. G of 1. Number 1, G is 0. And then G of 0 is 2. And last but not least, H of 0. H of 0 is 5. And G of 5. G of 5 is 0. Okay, questions on that? Are we okay? Okay, awesome. Oh, I need my notes. Sorry. Plus, I need to know my role in case anybody else comes in. Not very good. Oh, it's like the 5th time I've almost dropped the iPad today. It's been a rough day today, ladies and gentlemen. Okay, so let's see. So how is the inverse of a function form? So my notes look a little different than yours now because I had to add some stuff in since they told me to. So there's a few things added in, like objectives and I can statements and stuff. So those are added in. But other than that, most of the notes look exactly the same. I did add, like in this one, I added 2 pictures in. And I will pause so you guys can draw those pictures in when we get to that part. But for the most part, they're exactly the same. So anything like that says objective or I can statements, those have been added in because we have to have them now. So our objective for this section is to be able to find the inverse of a function graphically. And so first we need to know, how is the inverse of a function formed? Pretty easy. It's by switching TCHIN, switching the input. Oh, wow. By switching the output and input values. Okay, so here's my X, or my input, here's my Y, and then how I did it, how you find the inverse. So this is my function. This is my inverse. You just switch it. My y's become my x's and my x's become my y's, and that's it. That's how I find an inverse of anything. So if I have a set of ordered pairs, I would switch my x and my y's. If I had a graph, I would switch my x and y's and regraph it. If, let's see what else. So this is mapping graph. And we'll get to how to do an equation in a minute, but it's pretty much the same thing. I'm going to switch my x and my y's. So I'm going to switch the output and input values, or my x's and my y's. Okay, can I go ahead and go on to the next page? Is everyone okay? Enough time? Okay. So what is the notation for inverse function? Okay, great. So for a function, we use f of x, right? That's function notation. Or g of x, or h of x, or j of x, or a of x, whatever. Something of x. That's function notation. Well, if it's an inverse function, this is what it looks like. Exponent of -1 of x. And I know that's all. That's how you do it. And it's the inverse function, inverse of f of x. And that's all it says. Inverse function. So the notation is just, you just put a little exponent in between the f and the parenthesis of x, and it's just a little -1. So that's the notation. F inverse of x. Okay? Why do I have a graph there? It's a good question. Probably so we can see it graphically. Yeah, okay. So we're going to find the inverse for the next couple pieces here. We're going to find the inverse of the function. So if I have a graph, you don't have to do it graphically for a set of points, because how do remember on the last page, it said, how do you find an inverse function? I've switched the x and the y. So I'm going to take my x's, which are here, 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 and here, and my y's in each ordered pair, and I'm going to switch them. So my x becomes my y, and my y becomes my x. And that's it, pretty much. And so f inverse of x is going to equal the set of 3, 1, 1, 0. I'm running out of room, so I'll come down here. -1, 2, and -3, 5. And that's it. So if I have an ordered pair, honestly, all I do is switch my x and my y's. That's it. And we can draw it out graphically to see what it looks like. So if I graph the first set, I've got 1, 3, which is here, 0, 0, 1, which is here, 2, -1, and 5, -3 here. Okay, so it looks like this. Okay, and then if I graph the inverse, so it'd be 3, 1, 2, 3, 1, sorry. 1, 0 here. -1, 2. And -3, 1, 2, 3, 5 there. So there's the inverse of it graphically. Okay, so if I've just given a picture, a graph, how do I find the inverse? Again, I'm just going to take my points and I'm going to I'm going to flip the x and the y. So I'm just going to write my points down, and I'm pretty sure this is 1, 2, 3, 4, negative 5, 5. Well, negative 5, 5 becomes 5, negative 5. So my inverse point would be down here, 5, negative 5. And then this point here is negative 4, 1. Well, that point becomes 1, negative 4, so it would go here. And then this point here is 0, 0. Well, if I switch 0, 0, guess what I get? I get 0, 0, so it's still here. So there's my inverse function. Okay? Any questions on how do I find the inverse if I'm given a graph or a set of points? Because you guys are going to try it now. Okay? So I can go over this now. I'm going to make it bigger so it'll be easier for me to do. So the inverse for the first set is 5, negative 10, 9, negative 7, 6, 0, and negative 12, 8. Okay? Not too bad? Okay, so for the graphs, I would just find some points on the graph. So I'm going to look, and I think here's a point, and here's a point, and here's a point. So I'm going to use those 3 points because those are the closest ones I can find. So this is 0, negative 2. This is negative 3, negative 3. And this one is 3, negative 1. Okay, so, and then I'm going to flip them just like I did here. I'm going to take my points and flip them. So 3, negative 3 switches to, oh my gosh, 3, negative 3. That one's going to stay in the same spot. 0, negative 2 goes to negative 2, 0, which is here. And then 3, negative 1 goes to negative 1, 3. So my graph looks something like that. The top of this one kind of got a little wanky. Let's see if I can fix that a little bit. Something like this. Yeah, somewhere in there. Okay. And then I would go to the second one, and I would find some points again, and it kind of looks like it's probably going to touch 0, 0, and then here's a point, and here's a point. I only need a few, and sure, why not? We'll use this one. So 0, 0 is going to stay there, right? This is 1, 2, so it becomes 2, 1, and this is 1, 2, 3, 4, and 3, 4 becomes 4, 3, and then we've got 7. Is that 7? Let me bring it closer so I can see. Yes, 7, 6 becomes 6, 7. Okay, so it looks like it's going like this. Like that. Questions? Are we okay so far? And then the last one, I think it's the easiest one, because I've got a point here, and I've got a point here. And every point in between, I mean, it's every point in between. So I've got, this point is negative 4, 0, so I'm going to go to 0, negative 4. And this point is 0, 4, so we're going to go to 4, 0. And then, of course, it's every point in between. So my graph looks like this. So I want to kind of go smaller on this for a second. And I want to see if you guys noticed on these, there's kind of a, I don't know if I can do this on this iPad, on this program, not iPad. Let me see, is there a line? Nope. Nope. I don't think I can draw a line on here. I want to draw a, like have the computer draw a line, but it doesn't look like it's going to. So I'm going to have to do this. So please bear with me here. It looks like to me, if I draw a dotted line here, through here, look at that, what happens. And through here, and one more, sorry, I need to move it over a little bit, through here, that each one of these graphs is kind of reflected over that line. Doesn't it kind of look like that to you? It's kind of reflected over that line. And that line happens to be, let me tell you what that line is. That line is y equals x, right? My y-intercept is 0. It's going to up 1 over 1, up 1 over 1, up 1 over 1. So that line's y equals x. So it looks like the inverse is reflected over that line. It cuts it right in half. It's reflected over that line. Okay? So an inverse is just reflected over the line y equals x. Awesome. Okay? That's just like a little side thing that's kind of, we're going to talk about in a little bit. But that's it. How do you guys feel about this? I'm going to ask you actually, because I have to now. So we're going to do a little poll about, can you find the inverse of a function graphically? So, oops. Let me see. I think this is this one. So launch that. So if you will answer that poll, can you find the inverse of a function graphically? And then for me, for my knowledge and for me to know, if you put lost or kind of lost or totally lost, whatever I put my two answers as being with the lost, if you can just type in the chat box which part you don't understand. Do you not understand finding the inverse of a point or finding the inverse from a graph? What part on the graph did you not understand? If you could just tell me a little bit so I kind of understand what I need to do. Does that make sense? I need some feedback from you guys. "12 out of 14 of you have answered. So remember, alls we're doing, I just want to put this out here really quick. Alls we're doing is we're taking my x and my y, and what are we doing to it? We're flipping it. We're trading the x and the y. That's it. So whether it's on a graph or in a point, I'm taking my x and I'm taking my y, and I'm just trading places with it. My x becomes my y becomes my x. Does that help a little bit? That's all I did, is I switched my x and my y. If you look back at them. Okay? 13. So almost everybody's got it. Oh, so let me talk about that in just a second. Let me talk about that. So I did, and okay, are you done? Sorry, sometimes this doesn't quite end when it's supposed to. So the green line you don't have to worry about. I just noticed that if I drew that line in, it looks like the original graph and the inverse graph reflected over that green line. So the green line is just like, oh, look, it's a reflection over this line. So do you remember doing reflections, right? When you drew a reflection over something or over the x-axis or y-axis, and you drew the shape and it reflected over the line. I just noticed that it looks like it's a reflection. All three of them look like it's a reflection over this line. And remember, a reflection is the same, it's like looking in a mirror. It's the same distance away, right? So it just looked like all of these were a reflection. This one's a little crooked because my line's crooked. But it's a reflection over the line. And you can really see it if you look at this last one. These are all, this point, let me find, this point is the same distance from this line as this point is. They're exactly the same distance away. And every single point on this line is the same distance from the green line over. So the green line didn't have anything to do with finding the inverse. It was just an observation that I made. That's all. Okay, so it had nothing to do with it. And I'm sorry that kind of confused you. The other one, this was, the black line is, oh, you can't see me with my mouse is not making any difference at all. This line is the original graph. This line is the inverse graph. So this would be f of x, and this would be f inverse of x. Okay, that's it. Same over here. F of x, or g of x, or whatever you want to call it, and f inverse of x. Okay, so that's all. You don't have to draw the other line in there. I just made an observation. Okay, and we're going to actually come to that observation here. And it says it's f inverse is a reflection of the graph of f of x with respect to the line y equals x. You can see they're the same distance apart. If I look at it here, this is my line f of x, y equals x, and they're the same distance apart. Okay, same here. That's all they're trying to show you, is that they're the same distance apart over my line y equals x. It's a reflection. That's all they wanted you to see. Okay, so this graph, if this is my function, oh, that looks like that's my inverse. If that's my inverse, and here is my function, they're the same distance away from the green line. And that's all they want you to observe for inverses on a graph, that they're the same distance away. That's it. Okay? Nothing else. They just want you to realize that they're the same distance apart. Okay? That's all to these graphs. I have to take a horizontal line. Oh, my horizontal line is horrible. And so I have to take a horizontal line. And if it runs and it only hits the graph in one place, like it did here, which one's my function? This one's my function. And it only hits the graph in one place, then it has an inverse. That's it. That's how you tell. I need to quit talking about it because I'm going to get myself in trouble. Okay, so first of all, the next question says, do all functions have inverses? And how, oh, this is not the new one, because I made it after I did the new one. Dang. Okay, that's all right. So do all functions have inverses, and how do you tell if a function has an inverse? Well, how do I tell if it has an inverse? It must pass the horizontal line test. T-E-S-T, if I can spell. So how do I know if a function has an inverse? Well, it has to pass the horizontal line test as well as the vertical line test. So there is a horizontal line test, and it's exactly the same as the vertical line test. I have to take, I'm going to go back. How I tell algebraically if it's a function or not is if I do this. F of g of x equals x, or, this is a very important word, or g of f of x equals x. So if I put them inside of each other, we just did a whole bunch of compositions, right? Last class and the class before and the class before. If I put one of my functions inside the other and it simplifies and I get left with x, they are inverses. And this is what, this is the rule, right? This is how you're going to find out algebraically, and this is what you're going to use. Well, I've been doing compositions. Great. How am I going to find out if these two functions are inverses? Well, if I put them inside of each other, and I only have to do it one way. If I put it inside of each other, and it simplifies to x, inverse. If it does not simplify to x, not an inverse. Okay, so this is what I'm going to use right here. Probably 95% of the time to tell if something's an inverse. If they give me two equations, they want to know if it's an inverse, I'm going to take one and put it inside of the other. That's it. Okay, so we're going to get to that part because we're just talking about how do I tell if they're inverses. Now I want to say, how do I find an inverse? First of all, okay, great. We know how to find an inverse if you give me points. I know how to find an inverse if you give me a graph. Well, how do I find the inverse? How do I find the inverse if you give me an equation? Well, I guess I could graph it, but isn't there another way to find it if you just give it to me algebraically? Well, yeah, there is. Okay, and this is how you do it. Ready? Okay, listen very careful. There's 3 steps, okay? Actually, really only 2, but still 3. Interchange the x and y, or switch the x and y. I take the x, I put it where the y is. I take the y, I put it where the x is. Okay? Do you guys understand that step? So it's just like the point. I take my x, take my y, and I switch them. Okay? So I'm going to switch my x and y. And then, ready? This is hard. Solve for y. Okay? You guys have been doing that for a long time. Just solve for y. So I'm going to get with the y by itself, adding, subtracting, multiplying, dividing, whatever I have to do to get the y by itself. Okay? And then the last step says verify the f and f inverse are inverses of each other by showing that if I put one inside the other, I get an x. So we can verify. That's what they want us to do. Great. Because if we do that step and it doesn't simplify to x, then I did something wrong. Okay? So I've got 3 problems. Please make sure you're paying attention because this is probably one of the hardest things we've done this whole chapter, whole section. I guess they could be chapters, whatever. Okay. Where is my y? In problem A, where's y at? Can anyone tell me where y is? You can type it in the chat or you can say it out loud. I don't care. Oh, Orlando. Nobody knows where y is in my equation. It says f of x equals 2x minus 1. Not my y-intercept. I want to know what y is. Where is y in my equation?
The f of x?
Yes, it is. That is awesome. Another word for y is just f of x. So I can... Sorry. Let me go to a pen. This I can replace with y. So I can rewrite this as y equals 2x minus 1. Okay? Then the first thing it says to do to find the inverse, are you guys listening? Is I take my x and my y and I exchange them. So wherever there's an x, I'm going to put the y. Wherever there's a y, I'm going to put the x. So I'm just going to exchange these. I'm going to take these 2 right here. I'm going to take this one, and I'm going to switch them. Okay? Everyone okay? Does that make sense? Okay. So that means I get x equals 2y minus 1. Please make sure you ask questions as we're going along if you don't understand a step that I'm doing. Okay? So then it says, after I've switched the x and the y, it says to solve for y. So what do I do to solve for y? Anybody?
Get y by itself.
Yep. What am I going to do first?
Put the -1, add it to the side of the x.
Beautiful. I'm going to add 1 to both sides. That was great. So I get x plus 1 equals 2y. Okay? And then what am I going to do?
Divide by 2.
Divide by 2. And so I want to kind of stop here for a second. Normally, if I was putting it in slope-intercept form, I'd divide the 2 into both terms and everything. But I'm just finding the inverse. I don't need, it doesn't say I'm going to graph it. It doesn't say anything. I'm going to leave it this way. My inverse, f inverse of x, not y, f inverse of x, okay, equals x plus 1 divided by 2. That's it, done. I don't need to simplify it any further than that because the next step says I have to verify that it says, say in my directions, find the inverse of the function below and verify the inverse, right? So I have to verify, which means I have to find, which way do I want to do it? It doesn't matter. F of f inverse of x, okay? So I'm going to put f inverse back into f. So that means I've got 2 times x, but my new x is x plus 1 divided by 2. And if I leave it this way, the math is much simpler than if I take that 2 and divide it into the x and into the 1 at the same time. Okay? That's what I'm saying. So leave it in that form. Oh, I think a lot of people must have had counseling appointments today. Okay. Oh, okay, you guys. Let's see. How do I want to see this? What happens to my 2's? Can anyone tell me what happens to the 2's? I have a 2 here. And I have a 2 here. What happens to those two 2's? Let me see if I can write it this way. I can write this as 2 times x plus 1 divided by 2 minus 1. Now what happens to the 2's?
Do you divide them?
Yeah, and what's 2 divided by 2?
1.
Yes, so they basically, what happens to them is they make a 1, which I can kind of say, I hate saying this, but I'm going to say it. It cancels each other out. The 2's go away, right? So I get, oh, no parenthesis. Sorry. Yeah, I can have a parenthesis. X plus 1 minus 1, which equals what? What's x plus 1 minus 1?
Is it x?
It is x, yes. Because plus 1 minus 1 is 0, right? So I get left with x. And there we just verified because it simplifies to x. Remember we said up here to show that they're inverses. If I put one inside the other and it gets to x, it's an inverse, which we did. We put what we found as an inverse inside the regular equation, and it simplified to x. Therefore, it is really the inverse. Even though we found it, it really is that it's we verified that it was the inverse. Okay? We're going to do it again. We're going to do it a couple times, okay? Okay. So let's go to B. Where's my y at? I think I need some more more space. There we go. I know I'm going over this kind of slow, but I want to make sure that you guys get this. Oh. Guess we can't go that slow. This is, well, we can. If it takes us 2 days to get this, it takes us 2 days to get this. This is y, right? So I can rewrite this as y equals 3x plus 4 divided by 5. And then I'm going to take my x, that's not an x, and my y, and I'm going to, what am I going to do with them? I'm going to exchange them, right? Okay. So I'm going to rewrite this as x equals 3y plus 4 divided by 5. Whew. Okay, what do I do first to solve for y?
Multiply by 5.
Very, very good. Multiply by 5. Okay, so then I get 5x equals 3y plus 4. So I'm going to subtract 4. And I get 5x minus 4 equals 3y. And then we divide by 3. So, oops, I don't want to write y because it's not really y. I'm done with the problem. So I want to go back to the original name, which was g of x, right? So this is g inverse of x equals 5x minus 4 divided by 3. And then we have to find the inverse. Okay, so g inverse of x is going to be 3 times 5x minus 4 divided by 3 plus 4 all divided by 5. Ugly, right? Order of operations. What happens to my 3's? They make a 1, yes? And then I get, sorry, can I slide this? I'm going to slide this up, sorry. Then I get 5x minus 4 plus 4 divided by 5. So I still have to simplify the top, which gives me 5x divided by 5, which equals x. Gonna say this, okay? It's long. It is long. But if you do each step, one step at a time, and don't try and skip steps, you will get the answer right, okay? So do it one step at a time, write everything out, okay? And you're gonna be able to get it. I promise, okay? So, how are we doing on time? 28. Okay, we're doing okay. All right, so I think we'll be able to finish this problem. And then we'll leave the next one for tomorrow, for Monday, whatever day it is. Okay, so we're going to do this, right? Switch my x and my y. So this is y. So I've got x equals the cubed root of 3y plus 1. Oh, I made my thing a little too long. Plus 5. Okay? Questions? Are we okay? All right, so how am I going to solve for y? Well, the first thing I'm going to do is subtract 5. So I get x minus 5 equals the cubed root of 3y plus 1. How do I undo a cubed root? Anybody? Let me ask this question. How would I undo? How would I undo a square root?
Square it.
Okay, so how do I undo a cubed root?
Cube it?
Yes, exactly. I'm going to cube it. So I'm going to cube this side. And if I cube one side, I've got to cube the other side, right? Whatever, the rule stays the same. It says whatever I do to one side, I've got to do to the other side. So I'm going to cube this side. So this side stays as x minus 3. Oh, that's not a 3. So sorry. That would be a 5. X minus 5 cubed. And then the cube root and the cube go away because we cubed it on purpose to get rid of the cubed root, right? So that's going to be 3y plus 1. And then to solve for y, I'm going to subtract 1. So now I've got x minus 5 cubed minus 1 equals 3y. Why can I'm going to stop and pause. I'm going to ask you guys a question. Why can I not take the negative 5 and subtract 1 from it?
Because it's in the parentheses.
Because it's in the parentheses. Very nice, Malia. I can't subtract 1 from the negative 5 because I'm doing other things to that negative 5 first. So I've got to write them separately. Okay? And then I'm going to divide by 3. And there we go. This is Q, I guess. I guess that's a Q. Q of x, Q inverse of x equals x minus 5 cubed minus 1 divided by 3. Okay. All right. We have a few. We have time. We're going to have you do A and B. Okay? Do these two. Okay? Because we don't have a lot of time left. We have 15 minutes. So I'm going to go ahead and switch the X. Here's my Y. Oh, I hate it when I have the highlighter up there. Here's my Y. So I'm going to switch my X and my Y, right? So I'm going to switch my X and my Y. So this becomes X equals the square root of 5y minus 9. So the first thing I need to do to get to solve for y is get rid of the square root. And how do I do that? What do I do to undo a square root? Somebody already said it. Square it. Yes, I'm going to square it. So if I square one side, I have to square the other side. So that gives me x squared equals 5y minus 9. Okay, then I'm going to add 9 to both sides. So this gives me x squared plus 9 equals 5y. Okay, and then I'm going to divide by 5. So this is h inverse of x is going to equal x squared plus 9 divided by 5. So if I was going to type this into the computer here, I would type it this way, right? So x inverse of x equals parenthesis x and then the caret key squared plus 9 parenthesis divided by 5. Okay? So that's how I would type it into the computer. Although somebody did it this way, which works too. X parenthesis divided by 5 plus 1 divided by 5. They just divided the 5 into both of them. That works also. This one's just a little cleaner looking. Okay? Is that okay? Questions? Everyone okay with that? Does that make sense? You guys okay? Awesome sauce. Okay. Let's do this one. So we've got y, and I'm going to switch my x and my y. Oh, she's in the waiting room. I'm so sorry. So glad some people have my number. They can text me when they're in the waiting room. Switch my x and my y, and I get x equals 2/3 y minus 5. Solve for y, so I'm going to add 5. And I get x plus 5 equals 2/3 y. How do I get rid of a fraction? Malia, I can't hear you.
You multiply it by its reciprocal.
I multiply by its reciprocal. Can you tell me what a reciprocal is?
Just turn it around. I don't know.
Yeah, I take the fraction and I do what? I flip it, right? The numerator becomes the denominator. Denominator becomes the numerator. So I'm going to multiply by 3 over 2 and multiply by 3 over 2. Okay? Very good. So that means that's a p. P inverse of x is going to be equal to 3 times x plus 5 all divided by 2. Beautiful, done. That's it. Somebody distributed the 3, which is fine. I think somebody wrote it as 3x halves plus 15 halves. Is that the same thing? Well, yeah, it is. Just take that 3 and distribute it through, divide by 2. That's the same thing, right? As long as they're equivalent, you are golden. Okay? Are we okay with that? Questions? Alrighty. How are we doing on time? 12:44. Let me see what our next page is. Oh, there's 2 more. Do you guys think you can do 2 more problems? Or do you want to wait till next? Let's go ahead. Let's finish this. You guys, let's finish. Should we just finish it? Do you want me just to do it and we'll just finish it? Should we just finish it today? Let's just finish it today. Okay. These ones are a little harder. Well, this one is a little, I don't think it's any harder. I think you guys could do it. You did the square root one, so I think you guys can do this one. So I'm going to switch the x and the y. Oh, this is a y. So I'm going to switch them, right? Switch them. So I get x equals y plus 3 squared plus 1. So I'm going to subtract 1. And I get x minus 1 equals y plus 3 squared. Okay, question for you guys. How do I undo a square? Anybody other than Malia know the answer? Square root. Thanks, Melanie. Good job. Yeah, I square root it, right? And if I square root one side, I'm going to square root the other side. Awesome. So this gives me the square root of x minus 1 equals y plus 3. And then I subtract 3 from both sides. Can I subtract the 3 from the negative 1? So can I take this 3 from this negative 1? Question, can I? Malia says I can't. Anyone else agree or disagree with her? The answer is you can't for the same reason as before, because the negative 1 is underneath the square root, so I've got to do something to that first. Square root kind of acts as a parenthesis, So I've got to do that first. So that would equal the square root of x minus 1 minus 3. And if you don't like to write it that way, I could also write it as put the negative 3 in front and then write plus the square root of x minus 1. That way it doesn't look like it's minus 1 minus 3. Does that make sense? Either way is acceptable, whichever way you like to write it. Not too bad, you guys. Not too shabby. Okay, how we doing? We doing okay? We still have time? Are we still doing good? We're doing great. Okay. Doing the same thing, exactly the same thing. You've already done one like this. This is X. Oh, no, this is Y. Okay, so I switch my X and my Y's. So that becomes X equals negative 4Y plus 1 divided by 9. What do I do first? Solve for Y. What do I do? Sorry. Multiply by 9. That's a 9 in case you can't read my writing. So I get 9x equals negative 4y plus 1. Subtract 1, and I get 9x minus 1 equals negative 4y. Divide by negative 4. And r inverse of x is going to equal 9x minus 1. That's a 9, not an a. Divided by negative 4. Done. Is that okay? Is it not too bad? Okay, can I ask about inverses in a table now really quick? Whew. Okay. The table shows men's shoes sizes in the United States and the corresponding European shoe size. Represent the function that gives the European men's shoe size in terms of x. Is f of x a one-to-one function? One-to-one function means it's the same as passing the horizontal line test. So for every x, a function means for every x there's one y. One-to-one means also for every y there's one x. So is it a one-to-one function? Yes, because for every x, there's one y, and for every y, oh, by the way, this is x. Let me help you out. This is y. So for every x, there's one y, and for every y, there's one x. Does that help out a little bit? You guys are so cute.
That Mom.
Oh, I needed to see who's on their camera, too. I haven't done this
Yeah,
all
Mom
period.
said hi.
Melee, what have you been doing all period? Jacqueline's on the period. Oh, Jacqueline's on there. Okay. Okay. Let me close you guys down again. I don't know why, because I'm looking on here. And then it said, oh, I should have put yes, yes. What's f of 11? You can type it into the box if you want, or you can just say it out loud. I don't care. It's f of 11.
It's 45.
Yes, it's 45. Good job. In case you didn't know, I go to 11, and I shoot over here, and oh my gosh, it's 45. Okay, so what's f inverse of 43?
10?
F inverse of 43. Oh, somebody said, sorry, I thought you said something else. Yes, it's 10. Very good. So the inverse of 43 would be 10. Awesome. So find F inverse of 41.
8.
Nope. F inverse of 41 is 8, but what's F of 8? Got to do two things. Yes, Malia, that is correct. 41. So y, and you guys are like, what? So you said f inverse of 41 was 8, and then I find f of 8, which is 41. Remember, there's two things to do here. It's a composition. So what's f inverse of f of 13?
47?
F of 13 is 47. Now what's f inverse of 47?
13.
There you go. Because this one, remember, it's a composition, so I have two things to find like we did last time. Nice job, you guys. Just want to say, you guys did awesome. Can I shoot you one more poll before we close? Poll, launch. It talks about what we just got done doing. Can you find the inverse of a function and determine if two functions are inverses? It's the hardest thing we've done so far, so I understand if some of you guys are gonna struggle with this a little bit. But I'm very proud of you guys, I have to say. I love this class. I want you guys to know that. I really do. This is a great class. Okay, only 9 of 16 of you have answered the poll, though. The poll. Poll. What's the difference between P-O-L-L and P-O-L-E? They sound the same, right? They're said the same? Poll and poll? Poll and poll? I don't know. Interesting. Okay.
One's a test and one you can dance on.
or attach your volleyball net to.
Or that too.
Yeah.
Accurate.
No, I was just wondering if there's a difference if you say them differently. I don't think so. Good job, you guys. Okay. I think that I don't even know what time it is. It is 10:53. You guys are wonderful. Remember, I put that due date thing on your Canvas page, so I should stop recording.